Today we're going to learn how we name and write formulas for binary ionic compounds. What does binary mean? Two. Okay. So when we look at binary ionic compounds, we're just looking at compounds that are made up of two different elements. Okay. And how do we tell those two different elements apart? Like when we're looking at a formula, how do we know that there's two different elements? Capital letters. Good. Okay, so if we see two different capital letters, we know we're looking at a binary compound. Okay. And then if it's ionic, that means it's going to be made up of a cation and an anion. Okay. Usually a metal and a nonmetal. The key is, though, these ionic compounds have to be electrically neutral. So when we write formulas for these compounds, the charges have to cancel. Okay, they have to become neutral. All right, so I have 3 steps to follow when we write ionic compounds. If writing out steps helps you, go ahead and write these 3 steps down. If you're more of a learn by doing type of person, we're just going to do some example problems on the next 2 slides, and we'll follow these steps also. Okay. So the first thing we're going to do, we're going to write the formula for each ion. By formula, that's the symbol and the charge. Then these have to become electrically neutral, so we're going to have to balance those charges. The way we do that is something called the crisscross rule. And then finally, if the subscripts can be reduced, we have to reduce them. Okay, so our first example, we're just going to write the formula if we combine potassium and chlorine. Whenever we write these ionic formulas, the cation always goes first. The anion always goes second. What kind of charge does the cation have? Okay, so the positive ion will always go first. Negative always goes second. Okay. So the first element is potassium. What's the symbol? Nope. Okay. All right, and then what kind of charge will potassium get? Okay, so a +1 charge. Then we're going to write the symbol for chlorine. What's the symbol for chlorine? Okay, and what kind of charge will it get? Okay, I'm going to put the 1s there because I want you to see this crisscross rule. All right, so this is step 1. You just write like the formulas and the charges for each of the elements. Okay, then the compound has to be electrically neutral. Okay, so we can't have the plus or the negative charge. Okay, so our next step, I call it the crisscross rule. We take just the numbers. Okay, so we take the superscripts. So the superscript for potassium will move down and become the subscript for chlorine. And then the superscript for chlorine will move down and become the subscript for potassium. Okay. Only numbers, no symbols, so it becomes K1, Cl1. Okay. And typically for subscripts, do we write 1s? No. Okay, so I'm just going to rewrite it without the 1s. We just write it as KCl. All right, we're going to do a couple more practice problems. Our next one is calcium bromide. What's the symbol for calcium? Okay, and what kind of charge does it get? Okay. Calcium's in the second column, so +2. And then what's the symbol for bromide? Br. And what kind of charge does it get? Okay. So we write our symbols and the charges, and then once we have our charges up here, what do? Okay, we crisscross them. Remember, numbers only, no symbols. So it becomes Ca1, Br2. And do we usually write the 1s? Okay, so I'm just going to rewrite it, omitting the 1. So Ca, Br2. All right, next, let's write the formula for iron 3 oxide. What's the symbol for iron? Fe. Does iron have like a set oxidation number based off where it is on the periodic table? Okay, so how do we know the charge for iron? Do you remember this from Friday? Okay, it's 3. So this number in the Roman numerals, that is telling you the charge of iron. Okay, so iron is a 3+ charge. And oxide is just oxygen. So what's the symbol for oxygen? Okay, and what kind of charge does it get? 2 minus? All right, so now we have these charges. What do you do with those charges?
Crisscross.
Okay, crisscross. So when you crisscross it, what do you get?
Fe2O3.
Good. Perfect. And I would just say it as Fe2O3. All right, let's look at magnesium chloride. What's magnesium? Okay, Mg with a +2. And what's chloride? Okay. Cl, what kind of charge does it get?
7? No.
-3. Right? No.
Just -1. Right. Check out the column it's in.
Oh. Oh, I was in the column over.
That's okay. Okay, so now, once we know the charges, what do you do? Crisscross. So we end up with Mg1, Cl2. Do we write the 1? Okay, so we're going to write it as MgCl2. All right, and then finally, we have lithium oxide. What's our symbol for lithium? L. Li. What kind of charge does lithium get?
1.
Okay, +1. Oxide is O, and what kind of charge?
-2.
Okay, -2. So once we crisscross, what do we get?
Li20.
Okay, Li2O. Okay, so let's figure out the formula for strontium sulfide. Okay. What's the symbol for strontium? It's on the left. Second column. Good. Sr. What kind of charge does it have?
2.
2. And then what do you think sulfide is? Okay, it's just sulfur. So what's the symbol for sulfur? Okay, and what kind of charge does it get? Good. Okay, so that -2 charge. We have our charges. What's the next step? Okay, crisscross. So if you crisscross, what do you get?
SR2.
Okay. If your subscripts can be reduced, they have to be reduced. So is there a lowest common denominator between those two? Good. Okay. So you'd have to divide both sides by 2. You end up with SR1, S1. And do we write the ones? Okay, so how would you write this one?
SRS.
Good. All right, now we're going to learn how to name. So basically the opposites of what we just did. So this time, if you are looking at the formula, how do we know what the actual name is? Okay. So the name is just the name of the cation. Okay. Nothing changes. And then for the anion, we keep the root part of the word, and then we drop the ending and add "ide." Okay. So for example, NaCl, Na is sodium. And then Cl is chlorine. However, how's chlorine going to end? Ide. Okay. So NaCl just becomes sodium chloride. Okay, let's do a couple practice problems. So we have CaBr2. What is Ca? Calcium. Okay, and then Br is bromine, except how are we going to end it? Bromide. Good. Okay, technically your first word should be capital, so capital C for calcium. Second word is lowercase. All right, next we have Sr2O3. What is Sr? Okay, strontium. What's O?
Oxygen.
Okay, oxygen, and how are we going to end it?
Oxide.
Good, oxide. Okay. All right, then we have MgCl2. What's Mg? And what's Cl? Chlorine, except what are we going to call it? Chloride. Okay, can you try the last one on your own? All right, what do we call Li2O? Good. Lithium oxide? Are we feeling okay? Okay. Okay, so those were our simple ones. Okay, there are some more difficult ones, and it has to do with the transition metals. Okay, so if you look back to the previous slide, notice all of those metals came from either the first or second column. Okay, those ones are easy because they always have a set charge. Okay, their charge never changes. Remember from Friday, though, we talked about how transition metals can have multiple charges. Yes. So if there's a transition metal in the formula, then you have to state that charge. Okay. So here we have CuO. Is copper a transition metal? Yes. So do you have to state the charge of copper? Yes. Okay. So the way we figure out the charge of copper, we look at whatever it's bonded to. So copper is bonded to oxygen. What kind of charge does oxygen get? -2. Okay. And these have to be electrically neutral. So what kind of charge does copper have to have? Okay, copper's got to be a +2. So when we name this, it'll be copper and then 2 in Roman numerals in parentheses. And then oxygen is still oxide. Okay, so from this point forward, whenever you're looking at an ionic compound and you're trying to name it, the question you have to ask yourself every time is this metal a transition metal? Okay. If your answer is yes, then yes, you have to figure out the charge and put it in the name. Okay. If the answer is no, then no, you don't have to figure out the charge. It's the simple way to name it. Okay. In addition to the transition metals, do you remember we had 2 exceptions also that behave like transition metals, and they are tin and lead. Okay. So they're not technically transition metals, but they can have multiple charges. So you also have to state the charge if it's tin or lead. Okay. All right, so is iron a transition metal? Yes. So do you have to state the charge of iron? Yes. Okay. So to figure that out, we look at the sulfur. What's the charge of sulfur? Okay, so it's got that -2 charge. So what does iron have to be to balance that out?
Positive.
Okay. All right, so what are we going to call this one? Good. Okay, and if we were going to say it, we would just call it iron 2 sulfide. All right, next we have CuCl2. Is copper a transition metal? Yes. So do you have to figure out the charge? Yes. Okay. To do that, we look at chlorine. So what's the charge of chlorine? Okay, -1. And what's the quantity of those chlorines?
2.
Okay, so we're going to multiply that by 2. So what's 2 times -1? Okay, so there's a -2 charge. So what does copper have to be to balance it? Okay, so copper's got to be the +2. So when we name this, it's copper 2 chloride. Okay, are you ready for the third one? Okay, Cr2O3, is chromium a transition metal? Yes, so do we have to figure out the charge? Okay, hang with me on this one. So if you're kind of like zoning out, now's the time to tune in. Okay. So yes, it's a transition metal. Yes, we have to figure out the charge. So we look at oxygen. What is the charge of oxygen always? Okay, oxygen's always that -2. How many oxygens are there? Okay, 3. So what's -2 times 3? Okay, so overall, this compound has a -6 charge. So what does the positive charge have to be to balance that? Okay. Got to have a +6. Now, how many chromium atoms are there? Okay, so this +6 charge gets distributed evenly amongst both of those chromiums. So what's the charge of an individual chromium?
+3.
Okay, so +3, I'm going to divide it by 2. This 2 is coming from the subscript. Okay, so that plus charge gets shared evenly amongst the chromiums. Okay. So that makes this chromium 3 oxide.